So in continuation of my data structure using stacks, I am going to take an application which is for sorting, called as a quick sort, which is also called as divide and conquer. We will see why we are saying this as a divide and conquer type, right? So first we take a look with algorithm techniques, what exactly we need to do in this quick sort, and then we will implement this in our program. We will see how we actually run and make how we actually make the program using different techniques, and what's the best and worst case scenarios also in this quick sort, right? So we will start with our understanding of algorithm. So let's take a very high level understanding of what exactly is quick sort. It's basically also called as a divide and conquer. The idea behind why we are saying there's a divide and conquer is, let's say we have any problem, for example, and if we divide the problem into two or more subparts, then we solve these subparts into I mean, first we resolve these smaller problems, and then we combine uh, all the solved part into a one answer. So in this way we will, if we try to solve the problem, it called as a divide and conquer. So how we are going to do in this quick sort algorithm? Let's say I'm having an array of, let's say, of 10 or 10 elements, for example. So what we do, we will divide the array into two sub arrays such that a, a first part of the array, which is called as the lower part or left part, is having all the elements which is smaller than the right part of the array. Alright, for example, if I take an array which is having any number of 10 elements, and if we just divide the array and we try to solve these two parts, and solved in such a way that the left part is having all the elements which is smaller than the right part of the element, right? And then we combine that lower and upper part or higher part. So in this way we will solve the complete array. It will be more clear when we actually see the real scenario. There is one more thing which is called as a conquer here. See, conquer here means we call function recursively. Means, let me take an example. Okay, so here is a very good example I have taken. See, for example, this is an array of 8 elements. Okay, so what we are going to do, we will have we will pass first of all we will take a function, and then we will pass three parameters over here. Number one is data. So this what this data will do, data is the array what actually we are going to take, and the left and right part are the lower and upper limits of that array. Means left is pointing this 12 and right is pointing this 13. These are the two lower and upper bound of this array, and then we will move towards our pivot element. See, the main idea behind pivot element, or what actually is pivot element, is we will take one of the element. For instance, I am taking the mid of the element of this array. We can take any element in this array as a pivot element, and we, I mean, all the things will move around this pivot element. Okay, so for instance, if my pivot element is 12, so we will try to make this array in such a way that all the elements which is smaller than the pivot element should be on left side, and then we will try to make the all the elements which is uh, greater than pivot element should be on right side. And then we will sort the left and right hand side of the array, and then if we combinedly see, the whole array will be get sorted. So the whole concept is moving around pivot element only. So first of all, let's see what's the algorithm actually doing. See, I have already appointed left to the very first place of the element. I mean initial bound condition of the array, and then I am pointing right to the last boundary condition of the array. Means the left is pointing to the place which is called as a 0. If I say the value of left here is 0 and the value of right here is 7. 0 1 2 3 4 5 6 7 8. Okay, it's 8. All right, see, this array is having element 9, so my last element, the value of last element is 8. Now what I do, I will pass this value to two other variables which is actually going to move in this array, which is I and j. So the value of I here is left, which is also 0, and the value of j here is 8, which is equal to right. Now there is one way we can do this also, like for example, I can place please consider mid as an pivot element. I can place like this also, right? But in this case, if I put mid as in left, means my mid would be, I am considering this value as a pivot element, right? But here in our case, I am considering the mid as in the actually the mid of the array. So for that, what I am doing, I am just adding the left plus right divided by 2 so that I can get the mid of the array. So if I, let me write one thing, like please consider mid as a pivot element in our case. So what would be the value of mid here? Means the data having the sum of left and right. What's the value of left and right? 0 plus 8, which is 8. So 8 divided by 2 is comes as 4. So the value of mid would be data at 4, which is 12, like 0 1 2 3 and 4. So the value of mid here would be 12. Right. Now I am having there is one more while loop, and what actually this while loop is doing, it will simply compare the pivot element or mid element to the left side of the element, right? The main concept here is I want all the element which is lower than pivot element should be on left side, and all the element which is greater than the pivot element should be on right side. This is my main concept behind this pivot element. Okay, so what I do, I will compare, I will see if my mid value, means what's the value of mid here? The value of mid here is 12. Means if 12 is greater than data at I is 0. Means if 12 is smaller than is equal to 12, no, 12 is not smaller than. In that case, we will skip this step. See team, I will explain the complete step again when actually I am going to write a program on this, but here I am just want to understand you that how this quick sort algorithm works. It's a very high level understanding, and it will be better if you also try to solve, if you also try to write in your own way, just understanding the algorithm here first. So here in case if is smaller than, then we will increment the value of I. Means, let's say for example here the value is for example 10, so we will this condition gets qualified, means the value at 12 is greater than 10. Yes, so in that case the value of I get incremented. So in spite of this value of I is 0, it will comes as, oops, just a second, it will comes as I is equal to 1. Okay, so in this way it will work. Now, so in this way we will move forward up to that place where this condition gets satisfied continuously. Let me undo this. Okay, now we will check if the value of mid is smaller than data at j. So that means here what I'm trying to say, that means is 12 is smaller than 13. Data of j means data at 8, that means 13. Yes, is smaller than. So we will increase, we will decrement the value of j here. So what will be the value of j now? The value of j now will be, earlier it was j is equal to 8, now it comes as j is equal to 7. In this way we will move forward towards mid part, and here we will again here we will move backward towards mid part, and here we will move forward towards mid part. And the moment when it's qualify, I mean every time if it's qualify, let's for example here the value of j is 7 and here the value of I is 0. So I mean and okay, now again if we check if value of mid is smaller than data of j, means the 12 is smaller than 10, no, so it will not get decremented this time. So my j, the value of j here is fixed. Alright, now I am out of this while loop now. Now if we check if the value of I is smaller than j, yes, the value of I is 0, the value of j is 7, so the value of I is smaller than j. Yes, it's qualified. So we will swap these values. Team, you can see I am just trying to pick all the elements which is lower than the mid value on the left side, and all the elements which is higher than mid value on the right side. So we will swap these two values. So this comes as in 10 and this comes as in 12, and then we will increment the value of I. That means now it comes as an I is equal to 1, and j again get decremented, so the value of j comes as in 6. So in this way we will continue the uh, this algorithm, and finally we will see this array get sorted, okay, from lower to higher number. How actually is going to sort it, we will see once we are going to write a program. So the main idea behind this quick sort is just take a pivot element and see if the element in the left side is lower than the pivot element, and see if the element in the right side is greater than in the pivot element. Alright, so in this way we will try to solve the quick sort algorithm, and here you can see I am just taking a mid value of the array as in pivot element. We can randomly pick any number. By the way, we can pick the first element, we can pick the last element. You can also try with other numbers also. Okay, so this is the basic concept of actually how how quicksort algorithm works. Let me repeat it again very quickly. We have, let's say we have an array of 8 elements from 0 to 8. What I am going to do, I am just initially taking a pivot element, which is in my case is 12. I mean, how did I get this pivot element? I have just added the left and right limit and divided by 2 so that I can get the mid of the element. In my case is 12. The value of the mid element is 12, and now I am comparing this pivot element with my left part. Okay, and in case if it's greater than my left part, I will continue incrementing this, and in case when it's get stopped, means once the once this condition won't qualify, we will freeze the value of I over there. Let's say in our case here, and we will check the mid value with our higher part on the right side of the part of the array. So we will consider if mid is smaller than data at j. So here the value of j here is, earlier it was 13, so we will see if 12 is smaller than 13. Yes, 12 is smaller than 13, then we can decrement it, as you can see. And once, I mean, in a similar fashion we will move towards mid, and once this j get freezes, I mean, when once these conditions get disqualified, that means our j, the value of j won't get decremented further. We will swap this value, means swap the value of j with swap the value at I, means let's say in our case 99 and 13, just an instance. And then again we increment the value of I by 1 and decrement the value of j by 1. So in this way we will move towards mid from the both end, and if we continue this process, we can see this array gets sorted. Right? How? I'm going to explain you in a very detailed manner in our coming program. Alright, let me take a program. Let me open Traversy. Yeah. So let me include our basic header file, and we start with our main function first. Let me write one more header file, include conio.h, because I'm going to use CLRS here, clear screen function. So void main, curly braces open and close. Now here I am taking an predefined array, the same a double a y. Okay, the same array which I have taken in our example, which was, I guess it was 12. Yeah, so the value of my array would be 12 comma 99 comma 4 comma 99 comma 12 comma 12 comma 13 10 13. Okay, 13 12. Okay, so this is the same element, 12 99 4 99, 12 12 13 10 13. Okay, and then let